Vice-Chancellor and Principal of the University of Johannesburg, and an accomplished scholar with multidisciplinary interests that include the theory of artificial intelligence and its application to engineering, computer science, finance, social science, and medicine. He has an extensive track record in human capacity development and has published 15 books on artificial intelligence. Prior to his current position, he was Deputy Vice-Chancellor for Research and Internationalization and Executive Dean of Engineering and the Built Environment, also at UJ. He was recently appointed Deputy Chair of the Presidential Commission on the Fourth Industrial Revolution. Welcome, Professor Marwala.
Thank you very much. Can you all hear me? Yes. I'm actually quite excited to be in Cape Town. I was a student here for 6 months. In 1991, I came to study a mechanical engineering degree, but I decided to transfer to a university in Cleveland, in United States. I left this beautiful town for a small town called Cleveland. So I'm going to be talking about the Fourth Industrial Revolution and its impact on society. And perhaps before I talk about the Fourth Industrial Revolution, I need to talk about other industrial revolutions. It is called the Fourth because there was the Third, Second, and the First. So the First Industrial Revolution happened in England. I was a PhD student in artificial intelligence at the University of Cambridge, so I know quite a bit about England. And if you just wander to a pub in England and you interact with locals, you get even more impressed how such people could have come up with the first industrial revolution. Of course, these are the people who go to the pubs, isn't it? So the reason why it happened in England, not in China or India, given their population density, was because of the scientific revolution that had happened. It happened in England. This is the scientific revolution that gave us personalities such as Newton, Maxwell, and so on and so forth. So because at that point we were able to use science to understand how nature works, the English people were now able to make machines that were able to do the sort of jobs that are done by human beings. Of course, not everybody was happy. Machines are taking away our jobs, some of them said. So some form of a trade union, they are called the Luddites, was created in order to fight this industrial revolution. We'll call it terrorism because they used to go sneak at night and destroy machines so that machines cannot take jobs from them. There's a movie that I watched about that whole episode. Many of them were actually arrested, and many of them were actually hanged. And the first industrial revolution moved on. It gave us steam engine that was very important for production and also for moving from one point to another. Now, the second industrial revolution happened at the turn of the last century. And this is the revolution that gave us electricity. And that gave us something called an electric motor. And it was a British guy. His name was Michael Faraday. Michael Faraday was playing around with a magnet. We all know what a magnet is, isn't it? We all know what is this thing that conducts electricity, like copper. If you take a magnet and you have something that conducts electricity and you move it, electricity is generated. And if you have that thing that conducts electricity next to a magnet and you put electricity through it, it moves. So this is an electric motor. So when you are at the airport and you are waiting for your bag and it comes to you on that it's not an assembly line. What do you call it? Conveyor belt. It's because of an electric motor. And this whole concept of electricity and the magnet has a bombastic word for it. They call it electromagnetism. But Michael Faraday was not an educated fellow, so he couldn't really make sense of this. Then another Scottish, the last time I called him British, the Scottish man came out of the audience and said, he is Scottish, not British. Not English. His name was Maxwell. Maxwell came up with the theory of electromagnetism. And for those of us who are scientists, we know about it. This is really about electricity, electric motor, and electric motor is what was used to produce, to form an assembly line that produced goods up to today much more efficiently. But this theory of Faraday could not quite explain what Newton had done. It couldn't quite talk to one another. And a Dutch physicist called Lorentz actually said, no man, I'm going to come up with some correction factors so that I can correct what Newton said so that it can tell me what Maxwell said. And he did not really know why those correction factors were like that. He actually won a Nobel Prize. It took Einstein to explain what was happening, and that was the birth of Einstein's theory of relativity. We tend to think the theory of relativity was named by Einstein. The paper itself is about electromagnetism. It was actually Max Planck who named it the theory of relativity. So it gave us the second industrial revolution, mass production of goods and services. Then came the third industrial revolution. So the third industrial revolution happened largely in the United States. So something called a transistor. This is something, it comes from semiconductor, something that conducts electricity under certain conditions. Now, if you can be able to conduct electricity under certain conditions, what it actually means, it means that you have an efficient switching mechanism. And if you have a switching mechanism, it means you can be able to use ones and zeros to communicate. The use of ones and zeros to communicate did not start with semiconductors. Some of us still remember a telegram, isn't it? It was switching on and off, and you will have somebody who will write ones and zeros and take those ones and zeros into messages. So what happened here was that whole process of manually switching things on and off and somebody decoding it was automated. We got computers, the electronic age. Now we are in the fourth industrial revolution. Now the fourth industrial revolution is driven by quite a number of technologies. On the cyber side, I'm using the word cyber because computers are becoming quantum. We're no longer using digital computers. Quantum computers are coming. Things like blockchain, Internet of Things, developments in this area, and also developments in the physical space. The limit to our computers is how do we manage heat. That is why if you have even your phone, after speaking for quite a few minutes, it becomes very hot, isn't it? Because of that heat, you can't make it smaller. If we could manage that, we could make it even much more smaller. So you have new materials like graphene, you have 3D printing, robotics, and things in the biological space. For the first time, we are able to edit genes of an unborn child. In China, somebody has just done that. He is in jail, by the way. He edited a set of twins that were edited so that they could be resistant to HIV. And the byproduct of that was that these kids actually have a much bigger memory than an average child.
Bigger memory?
Yeah. So, for the first time, it is now possible to buy intelligence, isn't it now? Which we couldn't do for many, many years. So the confluence of all these technologies is what is called the fourth industrial revolution. Basically, it's making machines intelligent. Now, how do you make machines intelligent? You use something called artificial intelligence. I did a PhD in artificial intelligence. I did not intend to do a PhD in artificial intelligence. I wanted to do a PhD in engineering. So when I arrived, I was at a college called St. John's College at the University of Cambridge. And I sat next to a friend of mine, a South African guy called Nando de Freitas. He works for Google DeepMind. And I asked him, so Nando, what are you doing your PhD on? And he said, artificial intelligence. I did not really know what it means. I had watched The Terminator, but the fact that the word artificial intelligence is mentioned, I just couldn't remember it. And the word sounded quite nice, so I decided to switch and do a PhD in artificial intelligence. So now, what is artificial intelligence? Artificial intelligence is the art of making machines intelligent. Normally, we use a criteria that was developed by a British scientist called Alan Turing. Alan Turing said that artificial intelligence is only realized when a human being, when interacting with such a machine, that human being does not know whether he or she is interacting with a machine or a human being. It's a Turing test. There are all sorts of claims of people claiming to have invented a machine that can deceive a human being consistently. But I don't think that is possible. If you are speaking to a machine, you probably will know you are speaking to a machine. So within artificial intelligence, you have different types of artificial intelligence. You have what is called soft computing. You have what is called computational intelligence. You have a dominant group of artificial intelligence techniques called machine learning. And within machine learning, you have what is called deep learning. And I will talk a little bit about it going forward. By the way, if you really want to know more, please go and buy my book. It's actually an excellent book on this subject. Now, this is an example of us applying work in soft computing. Soft computing is not data intensive. It's when you want to build intelligent machines, but you don't have a large amount of data. So you use something called fuzzy logic. Your logic will be fuzzy because you don't have enough data to build probability distribution. And this can be a powerful tool. So this is the work that I did with my student, Evan Hewitz. He now works for Standard & Poor in London. So we built a machine to play a game, a poker game. And one of the most important skills in poker, for those of you who play it, is the ability to bluff. So we built this machine, and it was learning and observing. And then on its own, it identified that the most critical skill or strategy was to learn how to bluff. So it learned how to bluff on itself. And I'm not bluffing, by the way. So this was an article in New Scientist where it was in 2007, I was still a professor at Wits University, where this software was able to do. And we did not have huge amounts of data. That's why we used soft computing. So this is an example of soft computing. Computational intelligence, this is the picture that I took going home. I come from the part of South Africa that is north of the Tropic of Capricorn. South Africa is not predominantly north of the Tropic of Capricorn. So I come from a place called Venda. So when I was going to home, I saw this very beautiful picture. You know what it is, isn't it? It's an ant hill. And this ant hill has these things that are on my hand. They're ants. You might be wondering, why do you have these ants in your hand? in Venda we eat these ants. It's not kosher, but it's very delicious. Somebody actually did a study at Wits to talk about the nutritional value of this. So there was an Afrikaans poet called Eugene Marais. So Eugene Marais looked at these ants to see how complicated they were and concluded that this must be intelligent. And he decoded the whole intelligence of the ants. By the way, what you are seeing here is the tip of the iceberg. I saw an American person who calls himself an artist. I don't think he's an artist. I think he was committing murder. So what he will do, he will cut at the top and go and boil aluminium and pour it into that thing. It's on YouTube. And then dig what is underneath. And what you see underneath is much more complicated than what you see here. The air conditioning of this system is much more efficient than the air conditioning that we build as human beings. So Eugene Marais actually realized that this is actually a very, very intelligent system. And he wrote this in a series of articles. He did not go for famous journals. He actually published all this work in Hayes and Water more than 100 years ago. And the Dutch Nobel Prize winner, who could obviously understand Afrikaans, read it and went and republished it all as his own work. We remember him for stealing Eugene Marais' work than for winning a Nobel Prize. But these ants are very, very intelligent. So what is happening now is that you can code that intelligence into a software. We call this, there's a software called ant colony optimization. Exactly the same principle. And for those of you who have observed ants, sometimes you will see them forming a straight line, isn't it? You know? Yeah. That is the shortest distance from their nest to where the food source is. And we are able to use that algorithm in electronic maps, isn't it? Because it's the same process. You want a shortest distance from one point to another. You might have constraints, and they are able to handle constraints very well, isn't it? You know, if there is a constraint, you'll see them doing that. So you have a whole generation of these algorithms. They are called computational intelligence algorithm. Now, machine learning, this is actually the neuron of our brain. And from the neuron of our brain, we're able to build an artificial neural network. You have input, you have output. Input can be the average temperature in the last 3 days. Output can be the average temperature in the next 2 days. It will be actually a weather prediction algorithm. So this is how we build artificial intelligence, by using neural networks. I went back to find out when was the first time I heard the word neural network. It was in 1987 when I was doing Standard 8. Our teacher played us the Terminator, the first Terminator. And there is some guy there who was working with this neural network program. Again, when it was mentioned, I couldn't make sense of it. But nonetheless, I did enjoy the movie. I did not have to understand what it meant. So, mathematically, this is how it is written. And this is an article that I picked. And the reason for that was because we wrote an article last year, where we were talking about the rationality of machines. If these machines are intelligent, are they rational? What is rationality? If they are statistical models, one of the big figures in statistics, John Box, is famous for saying that all models are wrong. No matter what model you create, it is wrong. But they are useful. but they're wrong. They are an approximation of reality, but not reality itself. So now what does all this mean when machines are intelligent? What does it mean they're rational? So that was the article that we picked that was trying to summarize what we were saying in the article we wrote. Now, deep learning is when the neural network is big. This is what Google actually uses. So you have huge amounts of data which you feed into this. Because it is deep, you are able to give it many information, and it is able to make sense of it. A few years back, we went to a country in Asia. I'm not going to mention the name of the country because the ambassador came and camped in my office after that. So in this fictitious, real Asian country, when you arrive in, when you arrive in at the airport, you take your passport, the part of your passport with your picture, you put it on a machine. Then there is a camera that is looking at you. And it verifies that the picture that it is seeing is of the same person as the person that it is seeing at that point. If it can't verify, it prints a paper, so you have to go to a long queue where you are going to be held by a human being. So it was four of us. It was me, Peter Veil, Bongani Ngulunga, and Oscar van Helden. As a Vice-Chancellor, I was the first person to get into this machine. And then I put this picture of my passport, and he said, no, I can't verify this person. Then comes Peter Veil, and it verifies him. Then comes Bongani Ngulunga. It couldn't verify him. Then comes Oscar van Helden. It was able to verify him. So I was saying, why is this thing discriminating against people of African descent? And the reason was actually quite simple, because these machines require lots of data. And much of the data that are being used are collected largely in North America and Europe and Asia, not in the African continent. I understand Facebook has been trying to gather huge amounts of data in the continent. They had some competition where you post pictures of yourself, young and old, so that they can collect that data and train these machines. So these things are actually very data sensitive. You need data as complete as possible so that you can be able to build these machines. And I will be able to explain some of the things that you can be able to build and so on and so forth. By the way, if you want to know more about deep learning, please go and buy my book. So this is an example of a robot at a university in South Korea. It is being driven by a human being, by a machine, not a human being. We lost firefighters in Johannesburg because when they got into a burning building, there was no water, and they perished. If you have something like this, you can be able to send it to do things. So you can see it is able to do quite complicated things, opening doors. I actually have a picture with this robot because I have spent time at that university. It is able to do quite complicated engineering work. And because of this, many people in industry are actually preferring robots over human beings. So now, if we move on, this robot is able to learn using neural network. It is able to sense its environment, it is able to react, it is able to drive, and it can walk. Because it can do all those things, it is almost human. Because it is almost human, we say it is artificially intelligent. But does it fall in love? No. It doesn't fall in love because it is not conscious. We do read about stories about machines conspiring against human beings. Until machines develop consciousness, I am not having sleepless nights. Can it be recruited by COSATU? At University of Johannesburg, we had a strike. And when we were having a strike, I really wished if we had robots that were working. You can work it 24 hours, and there won't be any human rights concerns. Okay, maybe there will be robotic concerns going into the future, because it is a machine. It's not a human being, So the reason why it is preferred is because when it does things, it does without getting tired. So artificial intelligence is not only just changing the world of work, it's actually also changing the world of economics. When I arrived in the United States as an undergraduate student studying mechanical engineering, and I had transferred from University of Cape Town, what shocked me the most was when they told me that you will have to do 12 semesters of human and social sciences. But I'm here to study engineering. No. Here, it doesn't matter whether you are doing engineering or computer science, you have to take 12 semesters of human and social sciences. We're not going to tell you what you're going to study. So I decided to take 6 economic classes. And secondly, I took 2 psychology classes. Then I took 3 acting classes. I was even in a play, My Children, My Africa. I was Tami in that play. Then I took 2 history classes. One, history of science and technology, where they prescribed Thomas Kuhn's book, when he introduced the terminology, the paradigm shift. I actually invented it in the 50s. So I got interested in economics. So artificial intelligence is actually changing economic theory. The theory of demand and supply, that's what you learn in microeconomics. Me and a friend of mine in Brazil, Fernando, we did an experiment to go to Amazon to buy the same book at the same time. And we had 2 different prices. You know why? Because Amazon knows my demand curve, and it knows Fernando's demand curve. And our demand curves are different. And because they are different, it means our prices are going to be different. Because our equilibrium points are going to be different. Equilibrium point is where your demand and supply actually meet. So what is happening with this technology is that it is individualizing pricing, because it is individualizing demand curve. Now, I have spent quite a great deal of time in Southeast Asia. I've been to India 16 times. And if you go to a market, those people who are selling stuff try to do exactly what Amazon is trying to do. They give you a good and they give you a price. You either accept it and you negotiate until you agree. So if you go and check the price of the same good, you realize that it's going up and down depending on how good you are as a negotiator. If you are a lousy negotiator, you are actually going to get higher prices than if you are a good negotiator. And then there are other theories that are changing. One of the theories that are changing is the theory of information asymmetry. Stiglitz won a Nobel Prize for this theory. And to explain information asymmetry, he uses the 2 car salesmen. One selling good cars, another one selling bad cars. But you as a customer, because of information asymmetry, you don't know which is which. And he asked a question, what happens to a good car salesman in that market? And his conclusion was that the good car salesman is going to go out of business if there is information asymmetry. And you can see the mechanics of why he will go out of business. He knows his cars are good. He's less likely to give a discount than the person who knows that his cars are bad. He wants to get rid of them before they start breaking apart. So because of information asymmetry, good markets are actually destroyed. So now what happens when we move trade into the online platforms and we use artificial intelligence? Artificial intelligence actually reduces the level of information asymmetry in the market. This is a course at Cornell University called Networks. I was quite excited that they are actually teaching our theory. I did this work with Evan Hewitz, who was my master's student quite a number of years ago. Market efficiency. If you go to the stock market, for those of you who play in the stock market, there's this thing called the efficient market hypothesis. An American gentleman called Professor Farmer won a Nobel Prize for this. Now, if you go to the stock market, for those of you who come from Johannesburg, I understand that the stock market used to be downtown. And it was very noisy. People were shouting and so on and so forth. And the way you physically look used to determine whether you are going to be taken to the trading floor. Apparently, they used to prefer people who were tall. Because if you are shouting a price, if you are tall, then you are seen. Secondly, they used to prefer people with a commanding voice. If you have a soft voice, you will never be able to make a trade, in that market. But that whole process now, the stock market has moved to Sandton, is very silent. And the reason for that is because it is all done electronically. In fact, I'm told that if you are in Rosebank and somebody is in Sandton, they always can be able to make a trade before you if you do it at the same time. So proximity to the stock market becomes very, very important. So it has moved to preferences of taller people who had commanding voices to people who have faster internets and ideally closer to the stock market. And because of this, people are also using machines to make decisions. So instead of you deciding that you're going to buy this particular stock, you can get an artificial intelligence machine to be able to do this. So what happens if you do that? The validity of the efficient market hypothesis actually gets very, very strengthened. This is an example of a newspaper. It was a German newspaper. I did an extensive study on the relationship between the adoption of artificial intelligence traders and the validity of the efficient market hypothesis. I think this is what it means. It means artificial intelligence makes markets more efficient. And efficient markets are good. It means nobody benefits unduly. You don't benefit because somebody has made a mistake. You benefit because you are supposed to benefit. You understand the market quite well. Now, given all this, if I could just go back. Given all this, the fact that the financial systems are now dominated by technology, what are the bankers of the future going to look like? So I wrote an article for Business Day where it was also republished in the Daily Maverick, where I was just talking about how will the bankers of the future look like. This is Michael Jordan, not the basketball player, the banker. He thinks bankers of the future will need to be engineers more than economists. I think that is actually what is going to happen. I think in 2015, there was a flash crash in the New York Stock Exchange. So it just collapsed for the moment, for the moment, and it recovered. And many people were quite concerned. So what has happened? And the conclusion that we have is that it was because of algorithmic trading. And now they have taken the idea that is from electrical engineering, in your houses, if there is a power surge, the system shuts down immediately, isn't it? So the same concept is now in the market. If there is huge movement, automatically the stock market is actually suspended. Almost like the circuit breakers that we use in our homes. So when people, instead of teaching people just accounting or economics, they need to understand technology. They need to understand society. They need to understand finance. Very, very, very important. And that is the multidisciplinary experience that I actually enjoyed as an undergraduate student in North America. So now, this is another, if we move on, I'm going to skip this in the interest of time. So this is the work that we did with my student, Megan Russell. So what happens is that you have an individual who had to have their voice box removed because of cancer, for example. So they can no longer speak because their voice box has been removed. But they can still move their tongue. So what we were asking ourselves was that, can't we devise a system that will look at the movement of the tongue and be able to recreate the speech? So this is the system that we design, and this is what you put in your mouth. And if you see what happens when you speak, depending on the movement of your tongue, especially when it touches the palate, it becomes a signal. And we take this signal and take it to a machine that is trained to recognize voices out of signals using neural network, artificial intelligence. It works very, very well. There are certain words that it doesn't work very well. Words that your tongue does not touch the palate, like "oh," doesn't work very well, and we can understand why, But for many of the words, it actually works quite well, and we have a U.S. patent on this. We have already sold it to General Electric, but it was quite a good invention. We even were covered in the MIT Technology Review, robot voice. And this was in 2009. So artificial intelligence has been around for almost 70 years now. But it is becoming much more prominent now than ever before. This is the work that we did with our student, Simon Scarrell. So this is a picture of the lung. And this is the device where we teach a computer to diagnose pulmonary embolism. And we did a study where we gave 10 doctors 100 images of the lungs. So they look at the picture and they make a diagnosis. Is there pulmonary embolism or not? And then it went, these were the difficult cases. We gave the doctor the difficult cases. And then we took the results and went and stored them. 2 weeks later, we came back to the same doctors. We gave them the same information. Half of them changed their minds. When they change their minds, it means misdiagnosis, isn't it? Somebody who was supposed to be helped was given a clean bill of health. Somebody who was supposed to be, okay, was given treatment, blood thinners in this case. So artificial intelligence makes decisions much more consistent. And studies have shown that human beings, when they make decisions, it depends on whether they slept well last night. It depends on whether they did not have an argument with their spouses. All those things actually cloud our decision-making system. But this artificial intelligence, when we tested it, it was able to diagnose accurately to 98%. Not good enough. We would like 99.999%. And it never changed its mind, which was very, very important. So this is the same thing. This is another work that I did with my student, Dan Golding. Can we use artificial intelligence to manage queues in hospital? This whole concept of managing queues in the military language is called the triage. When you are in the army, you are in the middle of a war, and you have 3 doctors, and you have 20 injured people, who is helped first, second, third, and fourth? So again, this was a system that we did for the hospital. We use reinforcement learning. When I learned about reinforcement learning, I did not learn about reinforcement learning in artificial intelligence. It's a big topic in artificial intelligence. I actually learned it in psychology. So when I was studying psychology as an undergraduate student in Cleveland, there was this story about a Russian psychologist called Pavlov. He used to have experiments with dogs. So he will feed the dogs, he will ring the bell and feed the dogs. Ring the bell and feed the dogs. And after several weeks, every time he rings the bell, the dogs start salivating because they're expecting to eat. That was the theory of conditioning. The mechanism of conditioning is what is called reinforcement learning. And that same mechanism is actually used now in artificial intelligence to build machines that are adaptive. Very, very important. And we also use genetic algorithm is computational intelligence. I told you about ant colony optimization. We're able to design the same type of algorithm using our understanding of genetics. Again, given all these things that are happening around us, how should we train doctors? Given the fact that many machines are able to do diagnosis much better than human beings, how should we train our doctors? I'm a big critic as University of Johannesburg is starting a medical school in 2 years. I'm a big critic of how we train our doctors. We take 18-year-olds and we put them in medical schools. I think that is wrong. You know, in North America, they say go and study whatever you want to study. And 4 years later, after you have completed your degree, then you can come to medical school. And the reason for that is because there are many other complementary skills that the medical training is not necessarily going to give you. For example, the understanding of technology is now becoming very, very important in medicine. So our doctors must be engineers. They should understand data. They should understand economics. They should actually become techno-health workers. And that has all sorts of implication on how we train the doctors. Now, this is another work that we did. We wanted to find out whether we can predict whether 2 countries will go to war or not. I did this with Monica Lagatio. She's from a town called Lecce in Italy. And when we did this work, we did not believe that you could train a machine to be able to predict whether 2 countries will go to war. And we created these machines. We even wrote a book on this. And it was able to predict conflicts. And conflicts are not necessarily military conflicts. They can also be trade conflicts. This work was translated by the Chinese military to Mandarin. You know, we used a German publisher called Springer, and they told me that they told us that, we have finalized an agreement with the Chinese military to translate your book. And of course, we use variables such as democracy. I wonder how they write that in China. So I was very interested to see how they were going to write my name. This is how they write my name. Ma means horse. Wa means a gutter of a roof. The second character, you can almost see something collecting water from the top. And a person in the carriage is la, to pull. So I am a puller of horses from gutters of roofs. So again, given the fact that machines are able to predict conflicts, how do we train our political scientists? I think they should understand data. Obviously, they should understand politics, political theory, but I think they should also understand psychology. The conflict between the United States and China over trade has deteriorated to a psychological conflict. Who is going to blink first? They should be data scientists, they should be information workers. I think they should be techno-social scientists. And this has all sorts of implications on how we restructure our degrees. This is the work that I did with my student, Busisiwe Vilakazi. Busisiwe did a master's with me. She's on the ESCOM task team now. So she worked for her master's with me, and then she went to University of Oxford, St. John's College, to do her doctorate. And when she was doing her master's, it was, how do you predict whether structures are about to collapse? This is a bridge in Sandton that collapsed and killed 3 people. Now, what has happened here is that we couldn't tell that that bridge is going to collapse. Now, what we wanted to do was to create a system that will listen to the vibration of the bridge and be able to determine whether that bridge is of good quality or not. The first person to teach me engineering was actually my grandmother. She used to make clay pots. And then I will go to the river with her. Now when I tell young people that clay is found next to the river, they don't really understand, And then she will go and get the best clay. When I went to the engineering school, they called that material selection. She was very good at that. Then she will come back and then she will form the pot. If I ask our students to do this, they want some computer-aided design software. But she will do that without this, and then she will go and put it in the sun until it dries. Can you cook with it? No. Then you put it in the furnace, and she will put it. She will heat it so hot, and then she will allow it to cool down slowly. We call it annealing in physics, and then she will knock each pot and listen to it. And based on the ring of the pot, she will know whether this is a good pot or a bad pot. But something started worrying me because as years went by, she was throwing away good pots. Do you know why? Her hearing was deteriorating. Now what we did now is the same concept. We put things called accelerometers. They measure the vibration of the bridge, and based on the vibration of the bridge, they are able to tell whether it is a good bridge or a bad bridge. And based on that, you can be able to evacuate people. We did write a book on this one. Now, maybe I should talk about this. I started working on this subject of aircraft. I wrote an article for, I think it must have been City Press, about the Boeing 737 MAX and why it collapsed. And what I found was that, okay, now we know what happened. I actually wrote the article just before, based on my expectation of what must have happened. The control system, there was something wrong with the control system. Now, why is there something wrong with the control system? One of the most important aspects about control system is that you must be able to model the system you are trying to control. unfortunately, modeling an aircraft is actually quite sophisticated. We use something, for those of you who are mechanical engineers, we use something called the Navier-Stokes equation to control this aircraft. So what we came to the conclusion of was that there was a failure in control system. Now we know that there was a failure in the training of pilots to be able to do this. Now, when you automate, there are 3 ways in which you can automate. This is controversial. The first one is human in the loop, which means whatever the machine does, a human being must finally give a go-ahead. People in the military prefer that. The second one is human on the loop, which means it's you watch what is going on. If something goes wrong, you intervene. And the last one is human out of the loop. It means you press it on and you go for a walk. Whatever it does is up to it. And now when we are talking about automation, we can see cases where human must be in the loop, isn't it? When a machine is doing a surgery on a human being must be at least on the loop, must be observing what is going on. Autopilot is human on the loop, and sometimes in the loop, and so on and so forth. So what we hear about the Ethiopian airline was that they did try to sidestep the automated system. That did not work because it was designed with human out of the loop. Very, very important. So now if we move on, I think this is really about it. So this is the world in which we live in. Automation is all around us. But we should not forget the issues of ethics. I've already illustrated some of this. Self-driving cars, Uber. Did you hear a story about Uber? No. Their self-driving car killed a woman. Yeah, that was last year, isn't it? Now, who is responsible for that? Is it the engineer who designed? If you go and check at the software, it probably looks very different from when it was deployed because these things are evolving. Evolution is very much part of intelligence now. So we need to get laws that are able to handle these issues. We know about Cambridge Analytica and its impact on elections, especially the US elections. We did some work when Cuban doctors were coming to our shores on designing machines that understand our speech. And we realized that Xhosa is very difficult to understand by a machine. Later on, we realized the reason why it is difficult is because Xhosa is not a clicking language. It's a Bantu language. The clicks were borrowed from Khoisan. And the clicks are only 5% of the language. So the machine does not have enough data to learn because it does not happen frequent enough. Again, if we don't start developing algorithms that will handle that, then we can exclude cultures and so on and so forth. Now, given all this, what do? This is the skills that we need in the era, complex problem solving, critical thinking, creativity. How do we embed all these skills in our lives? Jobs are going to disappear. New jobs are going to emerge. What do? Those are the questions of our time, and nobody really has a solution. I heard Bill Gates saying that because jobs are going to disappear, we'll have to start taxing robots. What is a robot? A Microsoft Word is a robot, by the way, because it has an automated spell check. In the 80s, you would have somebody who will come and look at spellings of